Hello everybody, and welcome to exercise 3 on page 62 of the workbook. Let's read this question together. They would like us to find the equation of the tangent line to the curve x cubed plus x squared y plus 2y squared equals 2. That's the curve that we're seeing over here, and to do that at the point 1.5, and then to sketch the line on the diagram that we're given. Okay, why don't we start with the sketching of the line? Okay, so where's the point 1 and 0.5? That's going to be right here where x is 1 and y is 0.5. And we want to find the equation of this line, the line that's tangent to the curve at that point. Okay, so to do this, let's remind ourselves of the pieces of information that we need to find the equation of any line. Okay, one thing that we need is the slope of the line, and another thing that we need is a point that's on the line. Notice that they give us a point directly in the problem, 1, 0.5, so we don't need to do that ourselves. That's given to us. What we do need to do, though, is to find the slope of the tangent line. Okay, and to do that, we need the derivative of our curve here. So we will start by taking the derivative of both sides. Okay, this is going to be an implicit differentiation problem like we've been doing in this section. Okay, and let's look at this term by term then. So we're going to start with the x cubed. That's just going to be an ordinary derivative with respect to x. Okay, we've only got x's in that expression, so we're going to get 3x squared. Then we come to x squared times y. Notice that that's a product of x squared times y, so we're going to be using the product rule to take that derivative. So we will get the first function times the derivative of the second, derivative of y is just y prime, plus the second function y times the derivative of the first, and the derivative of x squared is just 2x. Okay? Next thing we come to is the 2y squared. Remember that when you see this y that's sitting here, that's really representing a function. So we need to use the chain rule when we take that derivative. So we're going to get 2. And then the derivative of that y squared, it's like a u squared. We're going to get 2u times the derivative of the u, which is y prime in this case. Okay, and then over on the right, we're just taking the derivative of 2, okay, and that's going to give us a 0. Okay, so there's our derivative. Let's clean this up a little bit, just rewrite it. So we've got 3x squared plus x squared y prime. I'm going to rewrite the y times 2x by putting the 2 at the front. 2xy and then 4y prime equals 0. Okay, and we'd like to solve this equation for y prime. That's what's going to help us find the slope of the tangent line. All right, notice that there are two terms that have y primes in them. And so we're going to subtract the terms that don't have y primes to the other side of the equation. That is going to give us, over on the left-hand side, x squared y prime plus 4y prime equals negative 3x squared minus 2xy, it looks like. Okay, and since we've got all the terms with y prime in them on the left, we can factor. So we'll pull a y prime out, and we're going to get y prime times x squared plus 4y equals negative 3x squared minus 2xy. All right, and the last step to get the y prime by itself is just to divide both sides by that x squared plus 4y. Okay, there's our formula for y prime. Okay, and remember, the reason that we did that, the reason we took the derivative, is it's going to help us to find the slope of the tangent line that we're interested in. Okay, so the slope that we're looking for is just going to be this derivative evaluated at the point, let's see, what was our point? 1 and 0.5. Okay, so we're just going to take x equals 1, y equals 0.5, and substitute into this formula for the derivative that we just found. Okay, so we'll get negative 3 times Okay, x squared, that's going to be 1 squared minus 2 times x, which is 1 times y, which is 0.5, over, in the bottom, x squared is 1 squared plus 4 times 0.5. Okay, and then it's a matter of doing the arithmetic here. You can either do that in your head or you can take out your calculator. Either way is okay. And what you should get when you simplify that down is negative 4/3. Okay, and that number is the slope of our tangent line. Okay, so what we know then is that the tangent line that we're looking for has an m that's equal to negative 4/3. That's our starting point. We know that the tangent line has the form negative 4/3 x plus b. To complete the equation, we just need to figure out what b is now. You remember how we did that from earlier? Okay, we know a point that's on the tangent line. Okay, that was this point 1.5 that they gave us. It's also the point over here in our picture. So we're just going to take that value of x and y and substitute it in, okay, to figure out what the b is. All right, so can't get that in the picture, so let's just remember that x is 1 and y is 0.5, and we'll substitute those in. Okay, so 0.5 equals negative 4/3 times 1 plus b. Okay, and just see where this leads us. So let's see. 0.5 is a half. I'm going to just rewrite that as a fraction. Okay, and to get the b by itself, we'll just add 4/3 to both sides. Okay, and if you get a common denominator here, 4/3 plus 1/2, that's, what is that? 3/6, just to be safe, let's write it all out. 3/6 plus 8/6, so we're going to get an 11/6, it looks like, for our b. All right. And the last step is to just go ahead and substitute that b in. So now we know that the tangent line looks like y equals negative 4/3 x plus the b that we just found, which is 11/6. Okay, and we're done.